Hello and welcome to this next lecture on acoustics. We are looking at a finite string, forced string with a general impedance at the end. We are trying to find the solution. So, last time we had reached up till this point over here. So, I will continue. Now, I would like to find the relation between B tilde and A tilde. Okay. So, what I will do is I will subtract the denominator from the numerator and divide it by this sum of the numerator and denominator. Okay. So, if we do that, if I subtract denominator from numerator, I get minus twice B tilde e to the power of j k l, and in the denominator if I sum, I get twice A tilde e to the power of minus j k l, and I will do the same here on the right side, which is z m l tilde minus rho l c by z m l tilde plus rho l c. Okay. Let me take this. Okay. So, now this can go, this can go. Okay. So, what now we have, we can relate B tilde and A tilde. I will take A tilde to the other side. So, I have B tilde is equal to minus A tilde e to the power of minus 2 j k l into z m l tilde minus rho l c by z m l tilde plus rho l c. You just give this a number 3. Okay. So far we have juggled only with the boundary condition. Okay. So, now we have to bring in the first condition, which is the force. Okay. So, if we bring the first condition, F plus T minus j k A tilde plus j k B tilde is equal to 0. Okay. So, now we have two equations and two unknowns. So, we have to substitute one into the other. So, we will bring this into this was 1. Okay. So, if we do that, what we have, F minus j k T A tilde and then plus j k T into minus A tilde e to the power minus 2 j k l into z m l tilde minus rho l c by z m l tilde plus rho l c, that is 0. Okay. I have substituted for B in this equation. So, that now I have only one unknown. Okay. So, if we take everything that is A related onto the other side, I have F minus j k T then I have 1 j k T A tilde, I have 1 plus e to the power of minus 2 j k l z ml tilde minus rho L C by zml tilde plus rho L C equal to 0. If we cross multiply the terms here, so what do we get? I get F is equal to jkt a tilde jkt a tilde into zml tilde into 1 plus e to the power of minus 2 jkl. I have already started combining terms, okay, plus rho lc 1 minus e to the power of minus 2 jkl divided by zml tilde plus rho lc. Okay. Already from here we can get A. From this expression we can have A. Once A is known, B is known, and so we have the solution. Okay. But I am trying to see if we can get a simpler expression. Okay. So how do we do that? Now we have J, so F is equal to J K T A tilde Z M L tilde e to the power of minus j k l. I take it outside so that I have e to the power j k l plus e to the power of minus j k l plus rho L C 1 minus, I am sorry, so we will do the same here, rho L C e to the power minus j k l into e to the power of j k l minus e to the power of minus j k l close and z m l tilde plus rho L C. Okay. So this gives me a slightly better compact expression j k t a tilde. I will take this common, e to the power of minus j k l, then inside I have twice cos k l zml tilde plus 2j rho L C sin k l by zml tilde plus rho L C. Okay. So now we divide the numerator and denominator by zml. So we divide the numerator and denominator by zml tilde. So that gives me twice j k t a tilde e to the power of minus j k l into, I will also take cos k l outside, cos k l. So I get 1 plus j rho L C tan k l by 1 plus rho L C by zml tilde. Okay. So now we have the answer for a tilde. A tilde. This was f. Okay, this here is f. So what would that be? We just invert the whole thing. Okay, a tilde is f into 1 plus rho L C by Z M L tilde, this term, and the rest is in the denominator. Okay, so let me get all of them here. 2 j k t e to the power of minus j k l cos k l, okay, into 1 over 1 plus j rho L C something I missed. This should have a ZML, sorry. Okay, 1 plus j rho L C by Z ML tilde tan KL. That is A. So that is the A over here, and once A is known, B can be known. Okay, B is simple enough after that. So B tilde is equal to with a minus f by 2 j k t e to the power of minus j k l cos k l. Okay, so this part is Z M L tilde plus rho L C by Z M L tilde, and this part is 1 by 1 plus j rho L C by Z M L tilde tan K L, and this term has to come in, which is Z M L tilde minus rho L C by Z M L tilde plus rho L C. Okay, so you can see that this term will cancel, this term cancels, and we have as minus f by 2 j k t e to the power of minus j k l cos k l 1 minus rho L C by Z M L tilde into 1 by 1 plus j rho L C by Z M L tilde tan K L. Okay, so now we have to combine both of these to get the solution. Okay, so the y tilde x comma t is a combination of these two. So let's combine that. So I would like to, let's copy this thing over here. Edit, copy, paste. Okay. Okay, so let me see. I don't want the intermediate, so let me just do that. Confusing, that's why. So let me put this as B tilde, and I will again copy this, cut it and then paste. Okay, so that's the B, that's B. Now if we pull these two together, y tilde x comma t is equal to a e to the power of minus j k x, right. So this term is common, the last term is common, so I will put it outside, okay, and then several things are common over here. So what I have is f by 2 j k t e to the power of minus j k l cos k l, that whole thing in front, okay. Then inside I have 1 plus rho L C by Z tilde M L, that constitutes my A, okay. Then e to the power of minus j k x, and then B has this minus, so I have to take the minus in, minus, then this term which is different, 1 minus rho L C by Z M L tilde into j k x, okay, and I can bring in my time if I want e to the power j omega t, and this common denominator 1 over 1 plus j rho L C by Z M L tilde tan k L, and this is nothing here, okay, okay. And now this e to the power minus j k L, I will take it on top, okay, and when I take it on top it becomes e to the power j k L, and that I will combine with this over here. So what do I get one last time? If I do y tilde x comma t is equal to f by 2 j k t cos k L e to the power of j omega t 1 plus rho L C by Z M L tilde e to the power of j k into L minus x, okay. Let me shift this a little, then minus 1 minus rho L C by Z M L tilde e to the power of minus j k L minus x, and multiplied by this common denominator, okay. So that is the answer for a general impedance, okay. Now I can set Z tilde M L to any value based on the situation and I will get the answer. So first of all, let us say we again have a finite forced fixed string, okay. That would mean what? I have a finite string that is fixed at this end is not allowed to move, okay. So f by v tilde v tilde is 0, so that is going to be infinity. So z tilde ml has to be set to infinity. If we do that, what do we get? We get y tilde x comma t is equal to f by 2 j k t cos k l, and then rho l c by, so there will be a bracket here, okay. So this will be e to the power of j k into l minus x minus e to the power of minus j k into l minus x, okay. And here also z ml tilde is infinity, this term goes, so it becomes 1, okay. That is about it. So now this into e to the power j omega t. Now this, if I further simplify, this is 2 j sin k l minus x. So that goes with this 2 j, okay. So we get y tilde x comma t is equal to f by k t sin k l minus x by cos k l e to the power j omega t. So this expression is correct, okay. So this expression here that we have is correct for a general impedance at the other end, okay. So now what we have is this. Let us look at how B and A are related. B tilde was equal to minus A tilde e to the power minus 2 j k l into z m l tilde minus rho l c by z m l tilde plus rho l c, okay. I think we had numbered this 3 or something, I do not remember, yeah, okay. So now for a forced fixed string, okay, if ZML is taken to infinity, ZML tilde is taken to infinity, okay, what do we get? We get B tilde is equal to this goes to infinity, and at the same rate this goes to infinity, so the ratio is 1. So I get minus A tilde e to the power of minus 2 j k l, okay. Now what we will do is we will take an expression out of this minus z m l tilde minus rho l c by z m l tilde plus rho l c and call it small r tilde l, okay. Small r tilde l is the reflection coefficient at x equal to L, okay. So reflection coefficient is the ratio of the reflected wave to the incident wave, okay. So, the reflection coefficient at L which is R tilde L, the ratio of the reflected wave to the incident wave. Now what is the, so I have a string I am exciting over here, what I am sending is A tilde e to the power of minus j k x, that is going, okay, and what is coming back is B tilde e to the power of j k x, okay, never mind the e to the power j omega t, and they are referenced, both waves are referenced to x equal to 0. That means at x equal to 0 their phase is 0, okay, x equal to 0 the incident wave is A tilde and reflected wave is B tilde, that is how they are phased. So at x equal to L the incident wave is A tilde e to the power of minus j k L and the reflected wave is B tilde e to the power of j k L at this point, okay. So what do we have, if I have a fixed value over here, okay, if I have a value that is fixed over here, so let me take this picture, let me take this picture. Okay, so if I look at the wave values at this end, the reflected fellow has B tilde e to the power j k L and the incident has A tilde e to the power j k L. If the end has to be fixed, if end has to be fixed, 0 displacement, okay, y tilde x equal to L comma t, if it has to be 0 then my B tilde e to the power j k L plus A tilde e to the power of minus j k L must be 0 only at all frequencies k is omega by c, omega is the frequency. So for all frequency values this has to be 0, only then end can be fixed, end is fixed. That is how the incident and reflected must be related, okay. So which happen, what does this do? This says B e to the power of B tilde e to the power j k L is equal to minus A tilde e to the power of minus j k L, and if I take this onto the other side, B tilde is minus A tilde e to the power of minus 2 j k. This is what we saw for the fixed end. Okay. So now what is the ratio? What is the ratio? We said R tilde L is reflected by incident. So R tilde L is going to be what? Is going to be B tilde e to the power of j k L by A tilde e to the power of minus j k L, which is equal to minus 1. Okay. So that means whatever was incident is completely phase shifted by 180 degrees and it comes back. That 180 phase shift holds only at the end point, okay, only at x equal to L that 180 phase shift works. That is why A e to the power of minus j k L is incident, the negative of that is what comes off from the other end. only then this summation is going to be 0. Okay. So, R tilde L equal to minus 1 stands for a fixed end. Okay. Now, that can be seen in the expression for RL also. So, RL tilde is minus ZML tilde minus rho LC by ZML tilde plus rho LC. So, for a fixed end we said F by V tilde has to be infinity, which is the impedance, and so in here if we set ZML to infinity, to do it properly we divide numerator and denominator by ZML. So, I have minus 1 minus rho LC by ZML tilde divided by 1 plus rho LC by ZML tilde. Now, I take the limit ZML tending to infinity, then this term is 0 and this term is 0 and I get a minus 1. Okay. So, this here represents the reflection coefficient. Add x equal to L. Okay. So, now if we combine the two waves along with this RL, okay, what that would look like is this the y tilde x comma t will be equal to the most general expression a tilde e to the power of minus j k x just hold on. Okay, we will do the other calculation first before we come here. Okay, the other calculation is this. Okay, so we have found the response to the most general situation. Okay. What is that? That is this y tilde. Let me write it once again. Y tilde is equal to f by cos kl twice j k t e to the power of j omega t 1 plus rho L c by z m L tilde e to the power of j k L minus x minus e to the power of minus j k L minus x 1 minus rho L c by z m L tilde into 1 over 1 plus j rho L c by z m L tan k L. Okay. Now what is the mechanical impedance? What is the mechanical impedance seen from x equal to 0? We have a string, we have something at the end, we are forcing it from the beginning. What is the total impedance of this system seen from the force when you have a general impedance at the other end? Okay. In order to do that, we need velocity. So del y tilde by del t, okay, that is equal to j omega f by let's see, twice cos kl j kt into zml tilde plus rho lc by zml tilde e to the power jk l minus x minus e to the power of minus jk l minus x into zml tilde minus rho lc by zml tilde into 1 over this term over here. Okay. So now I take off the j, I take off the j, I have k is kt, k is omega by c, t is rho lc square, this omega goes with that, c goes with c, so I have f by twice cos kl rho lc into zml tilde, and in here I have zml tilde so this I am computing at x equal to 0, right. I want the impedance at x equal to 0. So this x goes away, x has to be set to 0 now, this x set to 0 now. Okay. So what I have zml tilde into e to the power jkl minus e to the power of minus jkl. Okay, this sign comes in and this comes in, then plus rho lc into e to the power jkl. There is a minus here, there is a minus here, so plus e to the power of minus jkl, close it, and 1 by this term. Okay. So now this is 2j sin kl, this is 2 cos kl. Okay. So then that 2 goes away with this. So what we have is f by rho lc z tilde ml, and this cos kl I take it inside, so that I have j zml tilde tan kl plus rho lc divided by this term over here, which is 1 plus j rho lc by zml tilde tan kl. So this is the into e to the power j omega t. I must have forgotten. So e to the power j omega t. Okay. So, I will close the lecture with this. We have obtained a velocity, and from here we will obtain the mechanical impedance for the combined system and proceed further in the next class. Thank you.